professional. This is Hamad Abbas. I'm here with another video to share with you all. This is regarding high availability and disaster recovery. I have divided this video into two parts. The first part would discuss about what is high availability and disaster recovery is. What do you need to ask when you are designing the high availability disaster recovery is. Then we will talk about the different features out of the box available in Microsoft SQL Server for high availability and disaster recovery. We can compare some of those, and then that will be the end of the first part of disaster recovery. In the second part of the disaster recovery, we will have setup demos, and in those demos we'll talk about the read-only replica routing to read the data from the secondary replicas. Then we will also do the demo for how we can make the backups on the secondary replica. Then we'll do the last demo of how we can set up the sync replication with automatic failover. We will set up some transactions on the primary and shut down the primary and see how those records are flown and secondaries available using the listener. I hope that you will enjoy these two parts of the demos and the two parts. Let's start with the first part and talk about what do we need to know when designing high availability disaster recovery solution. So let's start with asking this question: what is high availability and disaster recovery? Different people have the different opinions about what is high availability and disaster recovery is. I have looked around different areas in the different blogs and found out that what exactly high availability is. High availability ensures that the component level recovery of a system. So what is component level? If, for instance, in a server, the memories got corrupted, the CPU got bad, or the disk got go bad. These are the different components. Even the server itself in a data center is the component. So if one of these things goes down and you still need to get the high availability in place, then you need to think about what do you need to do in terms for a business to run. That is in high availability. On the other hand, the disaster recovery is actually ensures that your site level recovery is possible. So for instance, if the whole site goes down, then you have to think about designing a system which ensures your system is still continuously working. So that is a high availability and disaster recovery is. Next question is, what do we need to ask when you are designing an HADR? If someone come to you and said that I want to design a high availability and disaster recovery solution of a database, and you are given this task, what do you have to ask to the business owners or the requester? Basically, there are few concepts or the few terminologies that you need to know. One is the recovery time objective. The recovery time object basically tells you what is the time that you can afford for a system not to be available. This is the definition that I have gathered from Wikipedia online. But basically, in a nutshell, what the recovery time objective is the time that you can afford for the systems to stay down, and the time that you need to have your system back online. For instance, I would say my RTO is 1 hour. So within 1 hour, system has to be back online. That is the time that you define upfront, and the system should be capable to be back online within that time. That's the recovery time objective. Recovery, the second definition or the second concept is the recovery point objective. The recovery point object focuses on the how much data that you can lose. So For instance, you are inserting the data into a database, and you know that you can afford to lose up to 5 minutes of data. Anything which is more than 5 minutes is not acceptable by the business because of the various reasons. So you have to think of the data that you can lose, and in that situation, you have to think about how often do you have to make the backups, or how often do you have to replicate the data to the different replicas or different sites or different servers, so that if one server goes down, one site goes down, your data replication, which is replicating the data to the DR site or to the different server, is available, and you do not lose that data. So that's an RPO. Now let's talk about what are out-of-the-box features Microsoft SQL Server offers to facilitate HADR. Microsoft, from back in SQL Server 6.5 or 6, there are different features were introduced. I'm going to go and walk you through the different features and what they offer. So start with SQL clustering. SQL clustering is a high availability solution with an automatic failover. What does it mean? That SQL clustering does not allow for a DR solution. It is only for an HA solution with an automatic failover. Clustering, I will talk more about the clustering, how the infrastructure is look like in a SQL clustering, but in a nutshell, SQL clustering is a high availability solution with an automatic failover. If one node goes down, the second node takes it over automatically, and you don't need to be available and do some manual work for a system to back online. Log shipping is our DR solution with manual steps that we need to do to fail over to the DR side. Log shipping is also out of the box feature, which is not HA. It is a DR solution. You can use it for an HA also, but typically scenario it is used for the DR purposes. Mirroring was introduced also later version of Microsoft SQL Server, and that is an enhancement of the log shipping. In the log shipping, I will walk you through about how the log shipping works, but in the later slides. But mirroring is an enhanced version, and it reads the logs entries from the log file and then applies it to the DR side. Geo clustering was introduced recently in SQL Server 2012, which is an HADR solution, but there are a lot of questions in the mind when you talk about how it works. And if we think about how it works, which I will discuss in the later slides, then you will be questioning, should I use it or not? So let's hold on to that thought about geo clustering. And we can discuss that in the later slide. Always on, which is also introduced in SQL Server 2012, marketing term always on. Basically, it is also an enhanced version of mirroring, which provides high availability and disaster recovery, both with a limited load balancing. What is load balancing? Is one of the features that database world, regardless of what is the vendor, Oracle or MySQL or Informix or Microsoft SQL Server, load balancing is always a challenge. But always on introduced very limited load balancing. We can talk about that as well in the later slide. Let's talk about clustering. What is clustering? So as we said, the clustering is a high availability solution. You have a site where you have two servers, and you can have more than two servers. Just to understand the basic concept, I have drawn only two servers here. If you notice that this is the primary server and this is a standby server on the same site, which is an active site. And then you have a shared storage. So the disk is a shared. This is in a typical active passive cluster. Active passive cluster means one node is active at a given time and the other node is passive. You can have an active also, where you have two SQL Server instances where one is active and the other is passive for one instance, and for the other instance you have the second node is active and the first node is passive. The intention here is not to talk about the details of different scenarios SQL clustering, but to talk about the fundamentals of SQL clustering. Then you have at the top of that setup, you have a SQL virtual name, which is nothing but the DNS name, which is a SQL Server instance name. And you need a Windows to be clustered. At the top of that, you need a SQL to be clustered. So that's the SQL clustering. Now, what is GeoSQL clustering is? The GeoSQL clustering is that you are going to have the two nodes in two different sites. The shared storage could be also on one side, a primary active site, or the secondary site, but also could have a third site where your storage is shared. Usually, you need a specific, very dedicated hardware for this clustering services to run and perform, because if you have a latency on the network due to each of these components are sitting on a different sites, then your performance will get affected. The point or the thought is that you're not only designing high availability disaster recovery, but also you have to make sure that the performance is not being sacrificed. So geoclustering, you can use it, but you have to carefully think about wherever you're putting these components, your performance is not sacrificed. Virtual name is same as in SQL clustering, so that part is still the same. Same thing, Windows clustering is fundamental that you need for, and then at the top of that you need a SQL clustering. Let's talk about the SQL log shipping. SQL log shipping, you have a primary server on active site, and then you have a secondary server on a DR side, which is a secondary site. You make the transaction log backup, then a process or a job in the SQL server copies that transaction log backups to the secondary server on a DR site, and a job or a process runs to restore those transaction logs in a periodic basis, and that's how the data got synced from a primary server to the secondary server. In case of a primary server goes down, secondary server, you have a data available, but you need some manual work that you need to take care before your secondary server is totally back online. And also the application and server has to be rerouted their traffic from primary server to the secondary server. So if you have a primary server name called primary server, then you have to change that server name to use secondary server as a database server name in the application or the web server configuration. So that's the log shipping is. Next, we talk about mirroring. As we said, the mirroring is an enhanced version of log shipping, in which a process which runs to read the logs from the primary server and applies those changes onto the secondary server. In mirroring, the database is in the read-only mode, but in log shipping you have an options to have a database in read-only mode or no read mode. Did I say the mirroring you have a secondary server in the read-only mode? No, it's not read-only mode. It's you cannot read the data. So in log shipping, the data which you have to read, if the time comes to restore the transaction log, all the connections will get disconnected. So that's what you have to remember. If you are running a report and at the same time the time comes to restore the database, you will lose that connection. And if the report is running and taking about half of the time, and the time is about, let's say, an hour, then you lose that time. So you have to very carefully design that system. In the mirroring, the data on the secondary server is not readable. So that's something that you have to keep in mind. Now, always on, which is an enhanced version of mirroring, and I can spend more time on always on because that's actually the feature which Microsoft have spent a lot of time and effort to put together a high availability disaster recovery solution, which really works. Always on does not require SQL clustering. It works on Windows clustering, so you need to have a Windows clustering in place. and you don't need a SQL clustering. You have a primary site and you can have a secondary site. In always on, the terminology that they use is replica instead of site. You can have an primary replica on active site, and then you can have secondary replica either on the primary site, active site, or on the DR site. In this example, I have two servers, which one of them, which is primary replica, is on the active site, and the DR replica, secondary replica is on the DR side. In the databases are in the availability group. I will talk more about availability group in the coming slides, but think about availability group is just a bucket where you can have your one database or more than one database sitting together, and that depends upon your application. So if your application is depending more than one database, and all of those databases will be grouped into the availability group. That is availability group. Same thing, a process runs and reads the log from the primary replica and applies those onto the secondary replica. You also have an options to route your traffic through the listener. So it's also a virtual name, but they always on calls it a terminology. It calls it listener. So basically, listener is also a DNS name which routes your traffic to right server. So if you want to have a connection that requires read and write, it will direct your connections to the primary replica. But if your secondary replica, which is configured to read the data only, then, and if you specify in your connection string that I just want to just read the data, then the listener will direct your traffic to the secondary replica. Depends on how many replicas you have, it will route to the right replica, but you need that requires some configuration on the always on site. In addition to that, you can also offload your backups to the secondary replicas, any of the secondary replica. That's where I have said that it has a limited load balancing. So load balancing, that you are balance your load. So you don't want your read traffic to be run on the primary, and you want to balance that and run it onto the secondary. Also, you don't want your backups to run on the primary. So you're doing the load balancing by not running that onto the primary and running it onto the secondary replica on the DR side. One more thing that you will also want to keep in mind, in fact two. One is that if your primary replica is a cluster and your secondary replica could be standalone or a cluster, then there's automatic failover is not possible. I will talk more about an automatic failover in a bit. Just hold on to your thoughts, but automatic failover is that if for some reason anything goes wrong on the primary replica, the SQL Server instance, the secondary SQL Server instance will take it over automatically, and that failover is automatic failover, which is not possible at this time in SQL Server 2014 if your primary replica is a cluster, SQL cluster. In addition to that, I also just talk about the how this routing take place from primary replica to the secondary replica, and how the secondary replica is actually get the connections to the server. Basically, there's an DNS name which actually knows what is my primary replica, but DNS name has some limitations. So time to live is one of the properties of Active Directory object DNS that has some time when it propagates the changes. That if my DNS entry is changes from primary server to the secondary server, it takes some time. Now if we depend truly on the TTL of a DNS, time to live properties of our DNS, then your client will have to wait that long until this changes of DNS is propagated from one site to other site, which will not fulfill the requirement of high availability. So what Microsoft has done is that they have coded the changes in the driver levels, which knows where to route. So if you are going to use this feature of always on, make sure that you should have drivers of client drivers of Windows 2012 or up. Something to think about it when you're designing a high availability disaster recovery solution. Now let's talk also about the difference between SQL clustering and always on. The first difference between the SQL cluster and always on is that SQL cluster provides high availability of entire SQL Server instance that include all the databases, which is the combination of users and system databases, linked servers and the logins. However, always on only provides high availability of a database or set of databases which are in availability group. So if you have 10 databases, and out of those 10 databases, 5 databases are part of a availability group, and if for some reason an instance or primary replica goes down, then only 5 databases will be available on the secondary replica, and the rest of the 5 databases will not be available. So something to think about when you are designing a high availability disaster recovery solution. The second bullet, I think, is not really a difference, but is something to keep in mind when you are designing high availability disaster recovery solution. Some of the third-party software which is not part of Microsoft SQL Server is not highly available unless third-party software is installed on all the nodes of a cluster or all the replicas of always on. For instance, I give you an example. If your application is relying to convert a document which is stored in the SQL Server to convert into a PDF, that you need a PDF converter, a third-party application. If you are using SQL Server to convert that as soon as the document comes in, then you have an application installed on each node which does that work. But for example, if that third-party software is not installed, then if you fail it over to that node where the software is not installed, you will see your application will not function correctly. Something to think about also. And the last difference which I have highlighted here is the shared storage. In SQL cluster, you have a shared storage. It's a single point of failure. Unless you are not certain that your storage is fully highly available and it has all the redundancy built in, you probably have a single point of failure. So pay attention to when you're designing your high availability disaster recovery solution with the SQL clustering. Your single point of failure is your shared disk. In contrast, always on has its own storage, a dedicated storage to each replica, which actually more expensive in terms because you have to double or triple your storage footprint. Now let's talk about the terminology used in always on. Always on, the terminology is one of the terminology that we touch base upon is the availability group. As I said, availability group is just the name, and it should be named as what the application name is, and then you put all of the databases for that particular application which is using these databases into this availability group. When we will do the demo, you will have more understanding of what the availability group is. But to think about an application which you want to make an high available, then next you have to think about what databases are being used by that application. You have to put all of those databases in an availability group, and then you name that availability group same as the application name. That's how you will think of an availability of an application. Once if a disaster happened, the failover of that availability group will go from one replica to the other replica. You cannot have one database sitting on one replica and the other database is sitting on the other replica if you design an always-on availability group. Replica is nothing more than a node, which is the term used in SQL clustering. Replica is a term used in always-on. In replica means you have a primary node, which is a primary replica. Then you have a secondary node, which is a secondary replica. You could have more than one secondary replica. There are limitations in SQL Server, which you can find out online. What are those? So then the listener. The listener is a term which is used in Oracle. It's a process which whenever clients connect, the listener knows, okay, where to go and make a call. So listener is in always on is a DNS name which which routes your traffic from a primary replica to the secondary replica. We can talk more about this in the demo and you will have more understanding each of this terminology even more. Now let's talk about manual and automatic failover. As I think also discussed about an automatic failover is where when we don't need any human interaction to initiate the failover, that's an automatic failover. And a manual failover is when you have to go manually initiate the failover from one instance to the other instance or one replica to another replica. Keep in mind these are just the definition. We will see these in more detail when we will go through the demo in the second part of this video. Last is the sync and async terminology. The sync is basically when a transaction is committed to the primary as well as secondary before a lock is released at the client in sync. So think of if you are making an insert statement on a primary replica, that insert has to go to the secondary or secondaries, depends on how many secondaries do you have, before the client releases the lock. The SQL Server will not release the lock until these transactions are fully committed to each of these replicas. So it's expensive, so you have to make sure your network latency is not bad, otherwise you will see all kind of issues when you set up the sync in always on. In contrast, async is not depending on releasing the lock to the client before it's commit to the secondaries. So as soon as it commits the transaction on the primary, it releases the lock, and later on the process commit those transactions to the secondary. So you have a risk if in case of a disaster your data might not be available, all the data available to the secondary. That portion, that time when it has not committed the transaction to the secondary, you may see this lost. There is something to think about when you are using or choosing sync between sync and async. That's the end of the discussion here. Hope that you like it. If in case you have any question, please feel free to email me aju90@hotmail.com, which I have listed here, a90remote@gmail.com, and I can see if I can answer those questions. I hope that you enjoyed it. There's a second part of this video coming, which will cover the demo on how you can fail it over, how you can route your traffic, and how you can make the backups on your secondary replica. Thank you.